Welcome back. Today we're going to learn a new technique of taking integrals, and it's the undoing of the chain rule. So if you remember from the chain rule, if you had an inside portion, maybe I wanted to find the derivative of e to the 10x, for example. I had an inside portion and an outside portion, e to the something, right? And so I would take the derivative of the inside times the derivative of the outside and then put the inside back in. So we're going to undo the chain rule here with what's called integration by substitution. So if you look at the first example, you'll notice that it's a more complicated example than we've done so far. 3x squared times e to the x cubed minus 1. And so what we're going to do is something called u substitution. I'm going to take that inside piece and I'm going to let it equal u. So u equals x cubed minus 1. That's the inside part I'm going to pick. So then what you do is you take the derivative of u. So du dx equals 3x squared. Next, I'm going to multiply both sides by dx, because the goal here is to get dx by itself, which I just realized there needs to be a dx here, so add that in. The goal here is to get dx by itself, so now I have du equals 3x squared dx. I want dx by itself, so I am going to divide by 3x squared. So now I have dx equals du over 3x squared. So that's the u part. Now we're going to do the substitution part. I'm going to plug u in where I see x cubed minus 1, and I'm going to plug du over 3x squared where I see dx. So over here now I have the integral of 3x squared e to the u, and then I'm going to replace dx with du over 3x squared. Now remember, the dx and the du is there to let you know which variable you're actually taking the integral of. So even though I've got x's and u's in my integral now, because of the du, I'm taking the integral of the u's. And so what you'll notice here is that these 3x squareds cancel, and I'm left with the integral of e to the u du. And now I can just take this basic integral. The integral of e to the u is e to the u plus c, and my last step is to plug back in u. So now I'm going to have e to the x cubed minus 1 plus c. That's the answer. So to recap, pick u. Find du dx. Solve for dx. Substitute. Integrate. And then substitute x back in. So we substituted to get rid of x, and then substitute back in to get rid of u. Get x back. So those are the steps for u substitution, and we're going to do another example on the next page. So we've got an inside piece here, 3x plus 4 to the 10th power. So I'm going to let u equal 3x plus 4. The derivative of that, du dx, is 3. So I can multiply by dx and divide by 3, and I have du over 3. So I'm going to substitute this into the original and this into the original integral. So now I have u to the 10th times 3, and then replace dx with du over 3. And you'll notice that the 3's cancel. Sometimes that happens, sometimes it doesn't. The goal is to no longer have x's in your integral. You can have different numbers, just not x's. So now I'm dealing with u to the 10th du. Well, the integral of u to the 10th, you add 1 to the exponent, so u to the 11th, and you divide by the new exponent plus c. And the last thing I'm going to do is plug back in so that I have x's instead of u's. So that's going to be 3x plus 4 to the 11th divided by 11 plus c. And that's your answer. Let's take a look at the next one. E to the x squared times 2x dx. I'm going to choose the x squared, and the more of these you do, the more clear it becomes what u should be. But I'm going to look at x squared to be u, because I'm thinking in my head, what's the derivative of x squared? It's 2x. Oh, that looks good. The 2x's will probably cancel. And like I said, the more of these you do, the easier it will be to figure out what should be u. Usually it's something on the inside of an exponent or a square root or parentheses. So u equals x squared. So du dx is 2x. I'm going to solve for dx. So du equals 2x dx. Divide by 2x. And so now I'm going to plug the du over 2x in, and I'm going to plug u in to the original equation. So I have e to the u times 2x times du over 2x. And you'll notice now that the 2x's cancel. So I'm left with the integral of e to the u du. Well, that integral is just e to the u plus c. And I'm going to back substitute in my x squared so that it's in terms of x again. So e to the x squared plus c. And our last example for the day. Before we start this new example, there's a typo I want you to fix. This should say 3x squared right here, not 3x. So go ahead and fix that before we do this example. So now I'm going to pick the denominator to be u because that looks the most complicated and it's inside a denominator. So u equals 1 plus x cubed, which means du dx is 3x squared. I'm going to solve for dx. And now I'm going to plug in du over 3x squared and the 1 plus x cubed, the u, I'm going to replace it in my original integral. So 1 over u, 3x squared, and then du over 3x squared. And the 3x squareds cancel. So I'm left with the integral of 1 over u du. Well, we know from our previous section that the integral of 1 over u is natural log of u, and I can back substitute what u equals 1 plus x cubed plus c, and that's your final answer. So that's the basics of u substitution. The next video, we're going to start doing some more complicated examples where not everything cancels and you have to do a little bit more work. So please rewatch, pause, rewind, whatever you need to do with this video to help you understand. And as always, come see me during office hours if you're stuck. Do not wait until 2 days after this assignment was due to come see me during office hours. The second you're confused, come to my office hours and ask questions. Have a great day.